Okay, here's Precalculus Concept 15D. We're going to use what's called the linear factorization theorem to find a polynomial with given zeros. So the way that I'm going to teach this or demonstrate this to you is just by running you through an example. There's only two boxes here and both of them are just examples, okay? So the hardest part I think about this is just understanding what the question is trying to ask of you. So it wants you to find a fourth degree polynomial. I'm going to call the polynomial f of x. It has to have real coefficients, and we know that -2, +2, and I are the zeros of the polynomial. And on top of all of that, we're going to add the condition that f of 3 must be a value of -150, meaning that when you plug a 3 into your function, -150 must come out of the function. Whew, okay, so here is the setup, and here is what I suggest that you do for these types of problems, okay? So first of all, we're going to start with the zeros, okay? So we'll make a list of the zeros. It tells me that one of the zeros is -2, so I'm going to list that right down there. It tells me that another zero is +2, so I'm going to list that right below it. And then it tells me that I, the imaginary unit I, is a 0, okay? Here is something that I'm not sure that you were aware of. Every time that we have an I or any kind of an imaginary root as a 0, we are guaranteed that its conjugate is also a 0. So what I mean by that is you'll notice every time we did the quadratic equation and we'd end up with something like -3 plus or minus, 4i over 7. Well, there are two zeros here. There's -3 plus 4i over 7. And there's -3 minus 4i over 7. So every time one complex number is a 0, it's guaranteed that its conjugate is also a 0. Okay, why do we care about this? Well, I'm going to tell you why we care about this. The reason is because in this particular problem, we were told that I is a 0, so therefore it must be true that -I is also a 0 because it's the conjugate of I. That's the one that we get for free. Okay, so these are my 4 zeros, which makes sense because I want a fourth degree polynomial. From the zeros, I'm going to move over into the next column and make the factors. Okay, the factors. So if -2 is a 0, then it must be true that x plus 2 is a factor. If 2 is a 0, it must be true that x minus 2 is a factor. If I is a 0, it must be true that x minus I is a factor. And if -I is a 0, it must be true that x plus I is a factor. So in this column, I list all of my zeros. In this column, I list all of my factors. And then from here, I make the polynomial. Okay, so the polynomial will be this. Polynomial. It will be f of x will equal some constant, which we're going to call a sub n for now, times each of my linear factors. X plus 2 times an x minus 2 times an x minus I times an x plus I. So this is the general form of this particular polynomial, given all the information that I have. The reason we need this a sub n out in front is because our constant out in front can be factored into each of our linear factors, and this is going to help us with this extra part at the end. Okay, so what do we do from here, you guys? All we do is multiply. So we're going to multiply these together, and then we're going to multiply these together, and then we're going to multiply the result together. Okay? So it's a lot of multiplication here. So f of x is going to be a sub n. Just carry that through for now. X plus 2 times x minus 2 is the difference of 2 squares. So that's going to become x squared minus 4. I just know that one. And then x plus I times x minus I is also the difference of 2 squares. So that is going to be x squared plus 1. Okay, so I have x squared plus 1, and I have an x squared minus 4. Now that I have those two multiplied together, I'm going to go ahead and multiply these together. And you can use the box method or FOIL or whatever you want. So I'm going to go ahead and say, all right, f of x is going to be my constant times, I'll use FOIL. So first is going to be x to the 4th, outer, plus an x squared, inner, minus 4x squared, and then last minus 4. Keep going, simplifying, equals my constant So this is going to give me x to the fourth minus 3x squared and then minus 4. Okay, at this stage of the game, when you have multiplied and simplified down to the last bit and you can't go any further, this is when you check and see what your value is going to be. We know that f of 3 has to be negative 150. So that means that when I plug a 3 in, I need to get out negative 150 back. Okay? So if I plug a 3 into this thing, right now, if I plug in f of 3, here's what I would get. I would get a sub n times 3 to the fourth minus 3 times 3 squared minus 4. So f of 3 is going to be a sub n. Okay, 3 to the fourth is 81. Minus 3 squared is 9 times 3 is 27. Minus 4. So f of 3 is equal to a sub n times 81 minus 27 minus 4 is worth negative 1, is worth 50, my bad, is worth 50, okay? 81 minus 27 minus 4 is worth 50. And f of 3, it told me, has to be negative 150, so negative 150 has to be a sub n times 50. So if I solve for a sub n by dividing both sides by 50, negative 150 divided by 50 is equal to a value of 3. So therefore, a sub n must be a value of 3. Okay, so finally now, when I'm all said and done, I know that this number right here is the value of 3. So my function is going to be 3 times all this stuff, x to the fourth minus 3x squared minus 4. If I distribute through, I get 3x to the fourth minus 3x squared, minus 9x squared minus 12. So 3x to the fourth minus 9x squared. Oh, this is negative 3. My bad. Negative 3, guys. Negative 3x squared plus 9x plus 12. My bad. I had a mistake there. Okay, so geez, let's check all this stuff out. So if I go over to Desmos, I already have it set up for you. And I graph for you negative 3x to the fourth plus 9x squared plus 12. You can see that a 0, one of the zeros is 2. The other 0 is negative 2, and when I plug in a 3, I get negative 150 out. Notice that you can't see the other zeros, which are I and negative I, because they don't exist on the x-axis. Okay? So that is how we do this first problem, and I'm going to do another one for you right now. Okay, so example number 2, find a third degree polynomial f of x with real coefficients that has negative 3 and I as zeros, and such that f of 1 is equal to 8. Okay, we're going to start the same way. So first I'm going to list the zeros that are given to me. So it tells me that negative 3 is a 0. It tells me that I is a 0. Now since I is a complex 0, I get negative I, which is its conjugate, for free. So there are my 3 zeros. From there, I'm going to build my factors. Okay, so if negative 3 is a 0, then x plus 3 must be a factor. If I is a 0, then x minus I must be a factor. And if negative I is a 0, then x plus I must be a factor. From here, I'm going to create the polynomial. So I'm going to say f of x is going to be my constant term times x plus 3 times x minus I times x plus I. And I'm going to go ahead and multiply. This is going to give me a sub n times x plus 3 times x squared plus 1, if I just multiply that out. I'm going to continue to multiply, so a sub n times, when I do all this, I end up with x to the third plus an x plus a 3x squared. I'm just foiling right now in my head, you guys. Plus a 3, and then that's going to leave me with, in standard form, x to the third plus 3x squared plus an x plus a 3. Okay, when I get it down to this stage of the game, I'm in pretty good shape. I just need to check to make sure that when I plug in a 1, I do indeed get an 8 out, right? So f of 1 is supposed to be a times a sub n times 1 to the third plus 3 times 1 squared plus 1 plus 3. So checking, I get f of 1 is equal to a sub n times, this is 1 plus 3 plus 1 plus 3. That's already 8. Oh, check that out. F of 1 is equal to a sub n times 8. And it's telling me that f of 1 is supposed to be a value of 8. So verifying here, I see that 8 is worth a sub n times 8. Divide and divide. So I get that a sub n is worth a value of 1. So what that means is that my original, way back up here, this one, is the function that I'm looking for. So the answer that I want, f of x, is going to be this function right here, since the value of a sub n is just 1. So it's going to be x to the third plus 3x squared plus an x plus a 3. Okay, so what the heck did we just find? We found a third-degree polynomial. There it is right there. Third-degree polynomial that has real coefficients. The real coefficients here are 1, 3, 1, and then 3. Negative 3 is a 0, I is a 0, negative I is a 0, and when you plug in a 1, you get an 8 back. So I can check all this on the graph over here. X to the third plus 3x squared plus x plus 3. You can see that negative 3 is clearly a 0, and when you plug in a 1, you get an 8 back. So this is the function that we were looking for. This is the one that we were asked to find.